in this video I'd like to know about a transverse electric mode for rectangular waveguide. So transverse electric mode of rectangular waveguide, the electric field intensity through the propagation direction is transverse. So that means the electric field intensity is in z propagation direction is nothing but z direction. The wave is propagating along z direction. So the z component of electric field intensity is 0 in this particular mode. So that's why it is called as a transverse electric mode. Okay, so that means the remaining components are present along the electric field intensity is present along x and y, and magnetic field intensity is present in x direction, y direction, as well as in z direction. So the analysis of a transverse electric mode is carried through a derivation. So it can be explained here.
TE mode for transverse electric mode, for TE mode. Okay, in the same way we will do the analysis, but before considering this, so in TE mode, which is meant by transverse electric mode, so transverse electric field, so in this case, so we'll consider the Ez value as the electric field propagating. So here the electric field is transverse to the direction of electric field is transverse to the direction of propagation, So you know that direction of propagation is towards the z direction. Okay, so as the direction of propagation is towards the z direction, so the Ez component is 0 in this particular TE mode. So in TE mode, Ez component is 0. So we will take the wave equation in order to derive the Ex, Ey, Hx, Hy values for TE mode. So we will take the wave equation for magnetic field in the direction of H. So we have already derived the wave equation for rectangular waveguide. So this is TE mode for rectangular waveguide. So we will take this equation. We will take this particular wave equation we have already derived in the last video. So we take that equation dou square Hz by dou x square plus dou square Hz by dou y square plus Hz of h square is equals to 0. So in manner we have derived in the last case, like h is having a components in x and y direction. So we'll take x and y as hz, where x is a function of x variable and y is a function of y variable. Okay, now substitute hz in the place of xy. So dou square xy by dou x square plus dou square by dou y square of xy plus xy h square is equals to 0. Okay, now we will take this equation out y. So y dou square dou square x by dou x square plus, similarly you will take here as x outside, so you can written as like this, xy h square is equals to 0. So now divide this equation with xy. Divide this equation with xy. So you'll get 1 by x here, dou x by dou x square. Similarly 1 by y, dou square y by dou y square plus h square is equals to 0. So this equation in the form of, so we can write 1 by x dou square x by dou x square plus h square is nothing but a. Okay, it's nothing but a square or a square. Okay, so we can say this is a square value. So 1 by y dou square y by dou y square is nothing but a minus a square. So we'll substitute in this equation. You will get a square minus a square is nothing but 0 in order to satisfy this equation. So we are taking that 1 by x dou square x by dou x square plus h square is equals to a square, and 1 by y dou square y by dou y square is equals to minus a square. Okay, now I'll take this first equation. Okay, so by taking this equation, so I'm writing here, so dou square x by dou x square plus h square minus a square is equals to 0. So this can be written in terms of b square. H square minus a square is nothing but a b square. That is the constant. Why? Because h is also constant and a is also constant, so we can written these two can be subtracted with another constant. So I can written here is nothing but a b square, which is equals to 0. Okay, so by using this equation, so we can written as 1 by x dou x by dou x square is equals to minus b square. So minus dou square x by dou x square is equals to minus b square x. So dou square x by dou x square plus b square x is equals to 0. So we can written x value. So this is a homogeneous second order differential equation, and the solution for this is can be obtained as like this. So k1 e to the power of jbx plus k2 e to the power of minus jbx. Okay, so this is the solution. So now this can be written in terms of cos and sine as k1 cos of bx plus j sine bx plus k2. Similarly, this can also be written in terms of cos and sine, so minus j sine bx. Okay, so as you got this, so now multiply this expression. So k1 cos bx plus j k1 sine bx plus k2 cos bx minus j k2 sine bx. So if you take a k cos bx as common, so then you will get a k1 plus k2 cos bx. If you take a j sine bx as common, so then you will get a j k1 plus k2 sine bx. So if this is k1 minus k2, why? Because this is a minus. Okay, so this is a k1 minus k2, so k1 plus k2 can be written as c1. So k1 plus k2 can be written as c1, and k1 minus k2 can be written as c2. Okay, if you substitute that expression, so c1 cos bx plus j c2 sine bx. So this is the expression for x, and now we'll see expression for y. So that can be obtained from this equation. So by taking this equation 1 by y, so again I'm writing here, so 1 by y dou square y by dou y square is equals to minus a square. So dou square y by dou y square is equals to minus a square y. So this can be again written as dou square y by dou y square plus a square y is equals to 0. So which is in the same form as like this equation. So this can be written in terms of x. So now this can be written, this equation can be written in terms of y. So it's the same solution, k1 e to the power of j a y plus here this is a k2 e to the power of minus j a y. So this can be again written as, so now directly I'm writing the solution in terms of c y is equals to c3 cos ay plus j c4 sin ay. Okay, so this is the equation of y, and this is the equation of x. So by using these two equations, you want to derive the hz equation. As you have derived the x expression and y expression, so now you need to substitute the x and y in the place of hz. So hz is equals to x and y. So c1 cos bx plus j c2 sin bx multiplied with c3 cos ay plus j sin ay. Okay, so this is the x and y values. Okay, now we need to take this and multiply this c1 c3 cos bx cos ay plus j. So this can be multiplied with this and this can be multiplied with this. So c1, so this is c4. Okay, so this is c1 c4 cos bx sin ay plus j c2 c3, I am writing here sin bx cos ay, so minus c2 c4, why, because j into j square minus 1, so c2 c4 sin bx multiplied with sin ay. So this is the equation for hz. Okay, now by using this equation, hz equation, so we will calculate the hx, hy and ex, ey. Okay, so now we'll see, before going to that, so we will see the boundary conditions, as boundary conditions are specified for only e components. So boundary conditions are specified for gz is equals to 0 when x is equals to 0 and y is equals to 0, x is equals to a and y is equals to b. So this ez value is 0 for all the conditions. So here we can know that from this equation. So boundary conditions are specified for only electric field, not for magnetic field. So we can solve this equation by using a ex, ey, hx, hy equations. So these are the formulas for ex, ey, hx, hy. We have already derived it in the last class. Okay, so we can see from this equation in the transverse electric mode, so we are substituting ez is equals to 0. So in this particular equation, if you substitute ez is equals to 0, what happens? These components are going to be cancelled, so only the remaining components, that means you can observe from these equations. So the differentiation with respect to hz dy by d, so with respect to y is equal to 0, so ex is equals to 0 here. So if you can observe this differentiation with respect to hz with respect to x, so you can observe that ey is equals to 0. So if you take these values, okay, so then it will be easy. So dou hz by, so if you want to find out ex and ey values, so we need to consider by substituting these boundary conditions in the place of dou hz by dou y is equals to 0 and dou hz by dou x is equals to 0, so that you will get a ex, ey, hx, hy values. Okay, so now this is the actual equation. So in this particular equation, so I am differentiating with respect to this with x, so that, so I will get minus c1 c3 b into, so integration of cos, sorry, differentiation of cos is nothing but a sine, so sine bx multiplied with b, again cos ay, plus here also you will get a minus j c1 c4 b multiplied with sine bx sine ay. So here you will get cos, so plus j c2 c3 cos bx multiplied with b cos ay minus c2 c4, so sin bx, so similarly you will get ikkada cos bx multiplied with b sin ay. Okay, so this is the formula. So now substitute if d dou h by dou x is equals to 0 when x is equals to 0. So if you substitute the x value as 0 in this particular equation, so the dou by dou hz value with respect to x is equals to 0. So now substitute the x value as 0 here. So this term is going to be cancelled. Why? Because sin 0 0. This term is also going to be cancelled. So you'll get the two terms. So the two terms is 0 is equal to j c2 c3 b cos bx cos ay c2 c4 cos bx b sin ay. If I substitute x is equals to 0, so in this particular equation, so j c2 c3 b cos ay minus c2 c4 b sin ay, which is equals to 0. Okay, so from this equation you observe that here two terms c2 and b are common. C2 and b are common, so take out the common values. So you'll get jb cos ay minus, here c3 will be there, jb c3 cos ay and c4 b sin ay. Here you can observe this equation is equal to 0, then so this should not be equal to 0. Why? Because these are the variable ay, y is a variable, so it cannot be 0. So c2 is equals to 0. If c2 is equals to 0, then hz value, so hz is equals to, if you put c2 is equals to 0 in this particular equation, so then the value becomes minus c1 c3 b cos bx, sorry, c1 c3 cos bx cos ay. If I substitute c2 is equals to 0 in this particular equation, so these two terms are cancelled, so you will get in two terms. So c1 c3 cos bx plus j c1 c4 cos bx sin ay. Okay, so these are the values. So by using this, now apply second derivation for this equation. Now for this, apply differentiation with respect to y, so and equate it to 0 when y is equals to 0. Okay, so this is 0 when y is equals to 0. So now differentiate this equation with respect to y. So dou h by dou hz by dou y is equals to, which is nothing but a, here there is a two terms with respect to, so minus c1 c3 cos bx, it is multiplied with a sin of ay, so plus j c1 c4 cos bx multiplied with a cos ay. Okay, so this is the differentiation term. If you substitute y is equals to 0, then dou h by dou y is equals to 0 in this particular equation. So 0 is equals to, so if I substitute y is equals to 0, this term will be going to be cancelled. Okay, so next this will be as j c1 c4 cos bx cos ay is nothing but a y. If I put 1 is equal, c cos 0 is nothing but 1. Okay, so in this particular equation, so this is the value in this particular equation. C, if I substitute cos bx is not equals to 0. Why? Because x is a variable. So c1, if c1 is 0 means the entire equation will be 0. If a c1 is equals to 0 means if I substitute c1 in this equation 0, so entire hz equation will be 0. Hz cannot be 0 in case of a transverse electric made. So we will equate c4 is equals to 0, then the equation becomes, if I substitute c4 is equals to 0 in hz equation. Okay, so hz is equals to c1 c3 cos bx cos ay. So this is the actual equation of hz. Okay, so now c1 c3 can be written as c, okay, c cos bx cos ay, where c1 c3 is equals to c. So we can written c1 c3 is equals to c. Okay, so this is the equation for hz. Now we want, this is the equation for hz. Now we substitute the another boundary conditions. So boundary conditions, So when x is equals to a, so dou by dou hz by dou x is equals to 0. Okay, so this is happens when dou hz by, so dou hz by dou x, if I differentiate this term with x, minus c b multiplied with the sine a bx cos ay. So if I substitute x is equals to a, then dou hz by dou x is equals to 0. So if I substitute 0 is equals to c b multiplied with sine b a cos ay. Okay, so if I put c is equals to 0, so then hz becomes 0, so c could not be equal to 0. So if I substitute cos ay, so cos y is a variable term, so it cannot be 0. So if I take this equation and equate to 0, so this is equal to 0. So sine ba is equals to 0 means sine ba is equals to 0 can be written as sine m pi. So sine m pi, this is the value. So ba is equals to m pi, a equals to, sorry, b can be written as, unknown is nothing but b. Here b can be written as m pi by a. So where m is equals to 0, 1, 2, so on up to. Okay, so this is the value of b, this is the value of b you got. Okay, so now substitute the value of b in this particular hz expression. Okay, similarly we want a value, so that can be obtained by using another boundary condition. So that is nothing but y is equals to b, dou hz by dou y is equals to 0. Want to substitute the another boundary condition, which is nothing but dou hz by dou y is equals to 0 when this y is equals to b. Substitute y is equals to b. So now I want first dou hz by dou y equation. So for this is the hz equation. So if I differentiate this c minus c with respect to y cos bx, so sine of ay multiplied with a. Okay, so now substitute y is equals to b, then dou hz by dou y is equals to 0 in this particular equation. So 0 is equals to minus c cos bx sine of ab a. So in this particular equation, if c is equals to 0 means the entire equation is 0, so c could not be equal to 0. So then sine of ab is equals to 0, so which implies sine ab is equals to sine n pi. So ab is equals to n pi. So b, so a can, so here a is unknown, so a can be, so a can be written as n pi by b. So this is the value of a, so this is the value of a. Okay, and we obtain this, so the a value is obtained. Now substitute a value and b value can be obtained. So now substitute hz value, hz is equals to c cos of b value is nothing but we have already derived, which is nothing but m pi by a x, cos of a value is nothing but n pi by b y. So this is the value of hz. Now we want hx and hy expressions. So these equations, so we can easily find out ex, ey, hx, hy. So we have already find out the hz equation. So we'll take these equations. So ex can be obtained as ex is equals to, so minus j omega mu by h square, so dou hz by dou x, so which is the value. So now, so according to this formula, so in this particular ex equation, dou ez by dou x component, ez component is 0. Why? Because this is a transverse electric mode. In transverse electric mode, ez is equals to 0. So the remaining part equation is this. So I have substituted, so I have written this. Okay, so this is the equation. Now substitute the differentiation with respect to this value. We have already derived the dou hz by dou x equation. So simply we can write that equation by substituting this. So which is nothing but a dou hx by dou, so which is nothing but c multiplied with minus cos, which can be written as sine. So sine, differentiation of cos x is nothing but sine bx multiplied with b cos of ay. So this is the value. So this can be again written as minus into minus plus. So j omega mu h square by c. So in multiplication of c into m, b is nothing but m by a. So substitute the value of b, m by a x cos of a value is n pi by b y. Okay, so this is the value of ex value is like this. Okay, so we have find out the ex value. So this is the value of ex. Now we'll see about ey. So what is the value of ey according to this equation? So if in this particular equation ez is equals to 0 means this is the remaining part. So I am writing the part. So j omega mu h square dou hz by dou x. So we have already written the dou hz by dou x. Okay, so we have already written the dou hz. So this is not the, so this is the ey, sorry, this is the ey value. Okay, this is the ey value. So ey is nothing but with respect to x. So ex is with respect to y. We have to derive it with respect to y. Okay, so here there is a minus. Okay, so due to this minus, this will become here, and this is ey. Okay, and this is ey. Okay, now we want to derive the ey value, so that we will take this equation. So ex, this is the ex. Okay, so ex means we have to derive it with the y expression. So we have already derived with the y, so which is nothing but j omega mu by h square dou hz by dou y. Okay, so this is a minus, so there will be a minus here. So minus j omega mu by h square. So we have already derived the dou hz by dou y, which is nothing but a minus. So I am substituting the value minus c cos bx sin ay multiplied with a. Okay, so same value I have substituted here. Okay, so in order to get the ex value, so minus into minus we will get plus. So j omega mu by h square. So substitute the value of b, and so b is nothing but a m pi by a x sine of n pi by b y. A is nothing but a n pi by b. Okay, so this is the value of ex. So we have find the equation for ex and ey. Similarly we will want hx. Hx is nothing but, according to this equation, hx is a minus gamma square dou hz by dou x. Okay, so this is the value. So here in this part dou ez by dou y is 0, so this term is 0. Okay, the remaining part is nothing but here. So hx can be obtained as minus gamma by h square dou hz by dou x. So we have already find out the value of dou hz by dou x, which is nothing but here. Okay, the value are directly I am substituting. So gamma h square, so which is minus c sin bx multiplied with b cos ay. So minus gamma by h square. So I am directly finding out it here. So minus into minus plus. So c sin b value is nothing but m pi by a bx sine of bx is nothing but m pi by a x cos of n pi by by. So this is the value for hx. So this is the value for hx. Okay, so now we want a hy value. hy. So by using this equation, hy is nothing but a minus gamma by h square dou hz by dou y. Okay, so minus gamma by h square dou hz by dou y. Okay, we have already differentiated dou h by dou y, so the equation is this. So directly I'm writing here, so minus gamma by h square minus c minus cos b sin x sin of a y multiplied with a. So I'm substituting a and b values. C multiplied with a is nothing but a n pi by b cos of bx. B is nothing but a m pi by a x sin of a is nothing but n pi by b y. Okay, so this is the equation for y hy. So in this way we have done the TE transverse electric mode Ex, Ey, Hx, Hy, and here in transverse electric mode there will be a Hz component. So that Hz is based on this equation we have derived this Ex, Ey, Hx, Hy. So these are the solutions, okay, for TE mode. Okay.